Okay, today's session we start Java collections. Okay, before we go hands-on, let's discuss about the theoretical part. What actually a collection? Why do we need collections? Where we are using collections? Importance of collections. We see that in most of the interview questions, right? They ask that collection framework, and collection. What is the differences? Okay, let's have a little description about this one. Okay, first, general meaning. It's a collection. What actually a collection, right? Collection means it's a group, right? It's a group of things or objects that represent as a unit. What is single unit, right? For example, if it's a real-time example, a group of employees, a group of student objects, right? All these are related to one single entity. Means it is a single. And so all these students are belongs to one group, right? Belongs to, right? For example, a group of employees, right, belongs to one department as a development department. A group of employees to testing department. A group of employees for HR department. Means all these group belongs to one single entity. Means they belongs to one department. So that is called a collection. That is a basic general meaning. We can't we call it as an interface also. Means all these employees, all these students are there, but each are they performing different tasks. All these HR department, but HR having different tasks on this. Like that's it's interface. Next, coming to this collection framework. In general, any framework, right? It's not only a Java collection framework. If you think about any framework, if we call it as a framework, means then it contains some set of interfaces, classes that make our Java application as a collection framework. Means it contains a set of classes, interfaces that are used for collections. Means it is a group of all these things in one place. And to coordinate that from interfaces to implementation class, then how this communication is happened, that's we call it as a collection framework. Next, coming to these collections, these are all utility classes used in collection framework, which contains all these static methods, which means we have this collection, right? This collection framework, it's a contents or list of all only interfaces. So to implement that, we need to have some classes. Those classes are called as a utility classes. That utility classes contains methods. What type of methods is all static methods? In these static methods, as well as we also have a abstract and default methods also. Okay, so what is a collection? Again, say it is an interface which can be used to represent a group of individual objects as a single entity. In Java collections, it is the root interface from which all the data structures are derived for this, so known as collection framework. What about the collections? This is a utility classes which exist in the java.util package that defines several utility methods, right? Static method, subtract method, default methods. Why do we need these methods? To work on this, to act on these collections for manipulating the data, like sorting, searching, etc. So it contains number of methods to do that. In Java, the collections, it is an architecture. Why do we, how do you say it's architecture, right? It's a type of an architecture which is used to store our data. Not only store data, we can manipulate the data also. So to do that, interfaces and classes will come into picture. With the help of these interfaces and classes, we are able to store the data and manipulate the data. So in Java, this collection is a framework and contains a lot of useful functions that make our programming makes easier. So why it's not only just to store the data and manipulating the data. Storing and manipulating the data is meant such a way that we also have to organize the data efficiently. Right, just storing data is not a fact, right? We have to organize data, how we can organize things in a data. So this called as a data structure also, right? A data structure in the sense that how we are structuring the data, how we are organizing the data, so make sure that it is feasible, it is easy, it will be helpful for manipulation. If you organize the things properly, right, it is easy to maintain or manipulate also. For example, take a real-time example. You have a bookshelf, right? Everyone have a bookshelf then used to store our books, right? Now you have n number of books of different categories: stories, fun, entertainment, so on, right? Reading books or skill set related. If you mix everything in that in one shelf like that, right, it is difficult for you to manage also, right? To pick up the book, then you have to search the entire shelf. If arrange the book such a way that according to the category like stories, fun stories, moral stories, and so on, right, that then you can easily go to that corresponding drawer and pick that book what you require, right? This is called as organizing the data. The way how you organize the data, that help you to manage the data, to manipulate the data, also to manage things. So again, said that is it. In Java framework, in this Java programming language, it contains a list of classes, set of interfaces and classes. It provides a platform which includes a collection framework, right, to manipulate our collections. Every class in the collection framework represent a data structure only, and we can achieve all these operations that you can perform on the data collections, which means that you have to structure the data on this using this collection so that it will help you for retrieving, searching, or storing, and insertion, any manipulation and deletion, right? So this Java collections will help this way. Let's look at this picture. See, this is the root interface iterable, and collection is derived from this iterable interface. And you see this, these are called as a collection part of these interfaces, right? These are all interfaces that derive from the root collection, and these interfaces are part of collections. And we say collections are the it's a list of all the interfaces and classes. You see this is the first level is called as a interface level. There's list, queue, set, map. There's also there map is different part, right? Then list, this is the color derived from the collection. List, queue, map, all these are the root interfaces. For this we need to have implementation classes, right? So this array list, linked list, vector list, all these called as a implementation classes for this list. For the queue also, dequeue, array dequeue, priority queue. All these are implementation classes used for this queue. And similarly for set also we have a number of this. Hash set is there, tree set is there, link set is there, sorted set is there. So depending on the requirement, we have to use that particular implementation class. If we have all these classes, when to use this and a particular implementation class for this is depend on our programming logic and depend on our requirement. Now you can have a question that if you have all the methods that are available in these classes, why do we need interface? Because see, if you use interface, using interface with the implementation class, it will give more control than what methods you have in this list interface. You can give access to manipulate your data only according to the methods available in the interface. As we seen this right in the previous sessions, we have a class can implement multiple interfaces. Depending on how you create an object to that class, it will give access to that methods for that interface. If you directly create an object to the class, right, then you will have all the methods access irrespective of the interface implements. We are giving control to that few methods to how to access and which methods we can provide to the outside world. Okay, now these are all the basic structure of all the collections. How do we see that? A list of classes and list of interfaces. Then the next step is we have to perform operation on this collection framework. So what kind of things we can do this rest? You can take step by step: list, vector, set, map, queue, and all we do. We will have a hands-on step by step. Okay, let's first understand what is the need of a collection framework. As told you, right, to store data. Before we go to that, to store the data in the sense, right, anyway we have other data types also to store data, but why do we need collection? Okay, let's take an example. Now we have a variable created to store data and a value is assigned, right? For example, string s equals to Java. Now, a developer or a programmer wants to store another data of same type. For example, as string s equals to AWS or Groovy, Python, something, what are them. Then what you do? Again, you have to create a separate variable like the next slide. Like if you have 2-3 variables, okay, up to that it is fine. Now the programmer wants to store more number of values, right? Let us assume 100 values in. Then the disadvantage is this, that you have to create that number of variables, right? To manage that data also, right? To say a string s1, I need a string s2, s3, s3, s4. How you manage this data, right? It is very difficult to maintain these many variables also. That is the reason collection has come into picture. Okay, so how this collection, the first step in this is to take an example of array. We have already discussed about the array. What is this array? Array is used to store the data of same type. What same type? If you create an array of string, then you can store a number of string values. And if you create an array of integer, you can have a number of integer values with the size declared during initialization. So that is why the collection is come into picture. Array also is a part of collection framework that is used to store elements of a particular data type. Now, this is why we need a collection framework. Let's think about list of classes, interfaces in the collection framework. In the next step, we will see step by step.